Welcome to our training webinar on PoE serial device servers and automation interoperability. Power over Ethernet, or PoE, is a standard that allows Ethernet cabling to simultaneously transmit data and power with a single network cable. It allows network installers and system integrators to install powered devices in locations without electrical circuitry. PoE serial device servers connect devices with RS-232, RS-422, or RS-485 serial interfaces to a local network for transmission of serial data over Ethernet. PoE Modbus TCP to Modbus RTU gateways convert and transmit Modbus RTU or ASCII data over wired or wireless Ethernet. Interoperability involves the ability of control or computer systems to exchange and interpret shared data. We will be going over applications, and at the end of the training, we'll be answering questions. If you have questions, enter them into the chat box, and we'll be addressing them at the end of the training. If you're working on any applications you want to go over, just let us know. I'm Maria Santella and am our sales manager. I've been with ICP DAS USA for 11 years and was an application engineer here in the past. I have Robert Morale, one of our senior application engineers, here with me with over 10 years experience in the automation industry. He'll be given an online demonstration later in the training on how to access a controller with SCADA software, which will be highlighting two masters accessing one slave. ICP DAS USA provides industrial control products and data acquisition system solutions that are low DC voltage and operate in extreme temperatures between -13 Fahrenheit to 167 Fahrenheit or -25 to 75 C. And that operating range can be extended with conformal coating. If you're interested, just let us know. ICP DAS, established in 1993, provides innovative industrial automation technology, ROHS compliant lead-free equipment, and is ISO 9001 certified. We manufacture our products in Taiwan, and we can ship within about a week or a week and a half. We have a knowledgeable team. Many team members have worked for the company for over 10 years, and we provide free consultation, can specify products for your applications, and provide free technical support. We can help you with questions, setting up equipment, troubleshooting issues. Our products are very reliable, come with the 1-year warranty. I've had customers open up control panels filled with snow, and they told me our equipment was the only product still working in there. We provide monthly training webinars on the latest industrial automation technology, and we have a library of training videos and other tutorials up on our website. We provide some free data logger software called Easy Data Logger, and it's for data logging, control, and monitoring. It's PC-based. It works with most of our data acquisition equipment, and you can use other vendors' Modbus devices as long as you have one of our Modbus devices in the network. Power over Ethernet allows for transmission of power and data through the same cable. It's often used in areas where electrical outlets are not available to provide power. Some devices that are commonly powered over Ethernet are IP cameras, access control devices, voice over IP phones, and serial device servers. One way power is provided over Ethernet cabling is a power over Ethernet switch. It's a powered device, and an Ethernet cable is attached to it, can be run up to 100 meters, and you can provide power to the IP camera. If you need to extend communication distances in Ethernet networks, you can use Ethernet switches, but in this case, the PoE switch is what's providing the power and the data. So the PoE switch is usually going to need the power to be powered by a power supply. A computer connected to the same network as the IP cameras through the router can see the video footage. Power sourcing equipment delivers a current voltage to a powered device over a regular Ethernet cable. In this picture, you hear, as I mentioned on the previous slide, there's a power over Ethernet switch, which is powered by a power supply. and the power over Ethernet switch through provides through the Ethernet cable power and data. Power sourcing equipment delivers direct current voltage to a powered device over the regular Ethernet cable. Power over Ethernet port sharing devices allow you to share physical COM ports among several applications. Once the COM port's shared, it can be opened by those applications at the same time. Modbus RTU is an open serial protocol derived from the master-slave architecture that's reliable and easy to use. And with Modbus RTU on RS485, you can only have one master. Serial port sharing devices like our TSH 700 series allows two Modbus masters to access the same slave device at the same time and are configurable over a web page. They're very small in size, about 2 inches by 3.7 by 1 inch, and they have a DIN rail mount. They have a DC jack for power input and come with a little DC jack connector if you want to use a standard power supply. They have low power consumption of 0.07 at 24 VDC. The TSH 700 serial port sharing devices can be powered over Ethernet by a PoE switch like our NS205 PoE or a PoE injector like our TNS 200IN. If powered by a PoE injector or standard power supply, they can be used with the standard Ethernet switches like our NS205s. They also do the Modbus RTU ASCII conversion. So a single Modbus RTU ASCII Modbus master device can communicate with Modbus RTU ASCII slaves using different protocols, baud rates, and data formats. So it's really great for application interoperability. They do baud rate conversions. So your PLC communicating over 9600 baud, for example, can communicate with your slave devices, communicating over 115,200 baud. They have a built-in read cache function that stores previous requests of the Modbus messages in the memory buffer. So when other HMI or SCADA master controllers require the same information from the same Modbus RTU device, the cached response is what gets returned immediately, which is why you're allowed to have two masters accessing the same slave at the same time. The TSH 700 PoE serial port sharing devices are being used in a lot of lighting control applications. This application example highlights two touchpads, TPD 703 7-inch Modbus-based touchscreen controllers. They're running programs in ladder logic, and these are configured as masters. They're connected to a TSH 735 serial port sharing device on two different RS485 ports. The other RS485 bus, our LC lighting control modules, are daisy chained. They have a 90 to 240 AC digital input and form a relay output. The touchscreen controllers are used to turn the lights in the room on and off. There are buttons configured for individual lights. There's also an all on or all off button to turn them all on or off at the same time. And the lights are turned off outside operating hours based on a schedule for energy management. There's also a manual switch in the room, which is connected to the AC input on the LC lighting control module. And that's used to trigger 3 relays that control the lights. Modbus is a simple and standard robust serial-based communications protocol widely used for industrial communications, for instrumentation, control, and data acquisition. Modbus RTU allows for communication over 2 insulated copper wires and allows for up to 255 devices in one network. It supports communication distances up to 4,000 feet, which can be extended with a repeater like our I-7510. Modbus applications are easy to deploy and maintain. Each Modbus device in a network is given a unique address, and only the node assigned as the master may initiate commands. Ethernet-based Modbus TCP networks use stateless connections, and it's possible for two or more masters to write to the same register or coil in a Modbus device on the network. A Modbus command contains the unique Modbus address of the destination device, and only the destination device will act on the command, even though the command gets broadcasted out to all on the network, kind of like Modbus, kind of like a UDP. Modbus commands contain check-in information that ensures commands arrive intact. Modbus commands can instruct a Modbus device to change a value in one of its registers, control, read an I/O channel, or to send back one or more values contained in its registers. Modbus TCP communicates over Ethernet networks, and Modbus RTU communicates over serial networks. You can use a Modbus RTU to Modbus TCP converter. It's also a power over Ethernet device, TGW715, a very popular converter. These are used to integrate network communication. You can use an RS485 to Ethernet converter like TDS715 if your computer doesn't have a serial COM port and you don't need to do that protocol conversion. You can see here in this page, a PC is connected to an NS205 PSE power over Ethernet switch, and it's powered by a 48 VDC power supply. An Ethernet cable is attached to NS205 PSE power over Ethernet switch, supplying power and data to our NS200 PS PoE splitter. The PoE splitter puts out a 24-volt output, which can be used to power equipment like our WinPack CE.NET programmable controller and our PET7052 power over Ethernet-based digital input and digital output module. So this is a PoE-enabled device, but in this application diagram, you can see that it can be powered by this power input here, or it can be powered by the power over Ethernet switch. So a PoE splitter is something that you can use to get power from a power over Ethernet switch and power some device. So not every device in your application has to have that power over Ethernet feature. Power over Ethernet-based Modbus TCP to Modbus RTU gateways have similar hardware to the serial port sharing devices and run special firmware that allows for conversion of Modbus RTU to Modbus ASCII. Modbus TCP protocol supports multiple Modbus TCP masters, and many buildings have Ethernet cabling installed, so converting the serial Modbus RTU to Modbus TCP helps improve performance and automation and application interoperability. The PoE Modbus gateway supports pair connection through Ethernet, so you can put one on each end to pass serial data over Ethernet cabling, or you can allow a single Modbus RTU master to communicate with a single Modbus TCP slave, as the gateway will act as the Modbus TCP master. Gateways help connect different networks using different protocols for automation interoperability. Gateways have special software running inside that helps with the translation of the information between the different protocols. Gateways allow different systems that speak different protocols to work together. For example, a gateway can allow an Ethernet IP device to be talking with Modbus RTU data. So for example, you can control Modbus equipment through an Ethernet-based PLC with our GW7472 Ethernet to Modbus gateway, Ethernet IP to Modbus gateway. In this picture here, the lighting control gateway, the DGW521, it allows for controlling dolly-based lighting equipment through Modbus TCP. These are some Modbus TCP-based programmable controllers. The PC running SCADA software. The controller software and PLC, they don't speak native dolly, but they're able to control the dolly lighting equipment for integration into the building management system. PoE is widely used in access entry systems. We offer these card reader devices here, and they're powered over Ethernet, and they can determine whether there's a whether the door is open or closed. They can be connected in the same network. They communicate over Modbus, and they can be used in conjunction with cameras, which can show the status of the door. And they can also be used with the gateways for communication back to a database or other equipment. Our serial device servers are commonly used in kiosk stations. There's a touchscreen device, and there's also input information, HMI information, and those are connected over serial, and they go back to an Ethernet switch over Ethernet back to a SCADA software running at the control center. So the ones that we talked about today, I mentioned we had the serial to Ethernet TDS 700. Those are the tiny ones. And then we also have the PDS 700 series, which also can run a C language based program inside. So if you not only need to do the conversion, but you also want to do some logic, it can do the IO control. And these can hold a memory expansion board inside if you want to add some IO. So we have many different kinds of converters and gateways. You can check them out on our website. We support many different protocols. Not all of them are listed here, but we do support CAN open. One of our very popular products is like a 2-port CAN gateway to Modbus TCP, the part number ECAN-240. We have DeviceNet, J1939 gateways. We support both Modbus RTU to J1939 and Modbus TCP. Modbus TCP one is the GW7238D. We also have GW7228. We support MBus, Profibus, Profinet, EtherCAT, Ethernet IP, BACnet, HART. We also have wireless, like a Modbus over wireless with the Zigbee, and we also have Wi-Fi IO. We have a very wide product selection on that. So as I mentioned, those device servers, they're commonly used in applications like kiosks. You often want to get like a card reader type device that communicates over serial, and you want to get it back to your Ethernet network to interface with your software running on a PC. So these devices, they convert serial to Ethernet, and on your computer, you'll see an actual virtual COM port after you set it up. Then you can interface with your serial-based equipment like your PLCs and different meters and instrumentation equipment. These can be powered over Ethernet, this TDS series. So you can power them with power over Ethernet switches or other kinds of power sourcing equipment. These kind of device servers, like I mentioned, the Ethernet IP-based PLC, you can use that to control different Modbus devices. So it's really helpful for integrating different systems together. These Modbus TCP-based IO over here, or these are actually Wi-Fi bridges. So these Wi-Fi bridges help allow, through this Wi-Fi access point, it allows this programmable controller to communicate with these wired type equipment over here over the Wi-Fi network. These serial device servers, they're often used to communicate with hundreds and hundreds of different RS-485 IO out in the field. They're commonly used in solar type applications. Automation interoperability, it allows you to work alongside and communicate with products from different manufacturers. So different manufacturers produce different kinds of equipment. Sometimes there might be legacy equipment out in the field that communicates over some serial-based protocol. You may never have heard of it. So we do provide C language-based controllers, and we do provide programming services in case you need to interface with some sort of serial strings. For example, a C language program can be listening in on that bus, and then it can do some different filtering of the different strings, and you can share that information with another device. So the interoperability of different systems helps efficiency, it helps productivity. And say you need to communicate with some old CNC machine that speaks some legacy protocol with a serial device server, you can communicate with that, and the serial device server can be running some sort of program that can be like a C language type program that can allow for easier and faster data sharing, right? Rather than having to go manually by hand, take account of different things. So now I'm going to be passing it over to Robert, who's going to be giving an online demonstration on how to access a controller with SCADA software. Two masters will be accessing the same slave device.
Thank you, Maria. Let's see. Hopefully you can hear me, but let's see. Let me just switch over my screen. Let's see, screen here, share. Okay. Maria, are you able to see my screen okay?
Yes.
Okay, so today I will be showing you our TSH 735 module in a Modbus RTU sharing application. Let's see, let me go to my first slide. It's a little blurry here, but let's see, this is roughly what we're going to do. We're going to connect two master connections to one slave device over here. So we're going to go use our TSH 735 with 3 RS-485 ports. So for my system, I will have essentially both are connected to my PC for this demonstration. But traditionally what happens is customers have an existing controller talking to slave devices, and they want to add either an HMI or SCADA or data logging computer to also monitor the status of the IO from the same Modbus RTU slaves. So instead of setting up a whole new system, they purchase a Modbus sharer like our TSH 735 and just add the second master device to the I guess network where you can communicate to the slave devices. Traditionally, Modbus RTU only allows one master device because it operates on a master slave configuration where the master sends a request, the slave device that's being spoken to responds to the master. When a second master were to communicate using the same bus, it would cause communication errors. So therefore, it's not allowed. And also the fact that RS-485 is traditionally used for Modbus communication, which is also half duplex. So you can only send or receive at one time. Let me show you the next slide. So what our TSH module does is if two commands come in simultaneously, it will send one command through, allow the slave device to respond, and forward the response to the appropriate master, and then send the second command through once the first command is either completed or timed out. So for this example, we're going to use, let's see, let me go to the next slide. Okay, so I'll show you the TSH configuration and what I set up. So our TSH module can be used for baud rate conversion or what do you call it, protocol conversion like Modbus RTU to Modbus ASCII or vice versa. But for this application, we're going to use our serial sharer application where we have two Modbus RTU masters and one Modbus RTU slave device. For Modbus RTU, you can use either mode, either serial sharer or Modbus sharer mode. I usually use the, what do you call it, serial sharer mode because it does work for both. And if you have like a more complex system in which you need to worry about packet combinations and stuff like that, you can use the Modbus sharer mode. But for this example, the serial sharer application will, or I'm sorry, mode will be sufficient. Let's see, so for this, you log into the module through the web server. This is just using Chrome. So essentially you assign the TSH 735 an IP address. You log into it using the web browser like Chrome, And you have these tabs at the top, which will allow you to configure the module. And later on, I'll show you the monitor tab as well. So let's see. So the mode I selected for our application today is serial sharer mode 1. And one thing you need to do is make sure you specify which port the slave device or slave devices are connected to. In this case, I'm going to have it connected to port 3 of the TSH 735. The rest of the settings we'll go over, at another time on a more dedicated webinar. But if you have any questions about this, we can go over that either after or if you purchase the module. So the next thing you want to do is configure the 3 COM ports. Now again, port 3 is connected to the slave devices, but port 1, 2, and 3 must be configured so that the baud rates match your 2 master devices for the corresponding COM ports and the slave devices for the attached to COM 3. So in this case, I'm going to use 19.2, 8, none, and 1 for all ports. Notice I have a master port on COM 1, a master connected to COM 2, and slave device connected to COM 3. Let's see. First thing I want to do is make sure I have my slave device configured. Let's see. I use our decon utility to configure our M7026 module. And one important thing is you need to know what Modbus registers you're going to be polling. So for this example, let's see, since the module has analog inputs and analog outputs, I actually wired one of the analog outputs to an analog input. And note that the registers we'll be polling are 30,001 and through 30,006, and also 40,001 to 40,006 correspond with the analog input values. The analog output values are Modbus registers 40,033 and 40,034. There's 2 analog outputs. This is the monitor tab for the web interface. This is a very useful tool for verifying communication is stable and monitoring for errors and anything in configuration problems. So at the top, you'll see byte counts. When communication's happening, you'll see these numbers increase. And towards the bottom, you'll see like error messages and exceptions. Let's see, which are very useful for verifying or finding out what the problem is on your slave bus. It could be something as simple as the baud rates don't match. If you don't see communication happening at all, maybe you have a loose wire, and so on and so forth. But this is a very useful tab for both showing the operation and verifying the operation is happening and making sure there's no communication problems. And let's see, lastly, at the very bottom where it says maximum slave response time, this can be very useful for setting the extended timeouts if it's necessary on your master PLCs to allow for the buffering and sharing of the COM port. Traditionally, what happens is customers will have one master device which is already working, and they're trying to introduce a second master device. If the second master device either polls slowly or the packets are small, it's usually not a problem. But if both PLCs or both master devices are communicating very fast, this may not be the perfect solution for you. So this application works very well with for data logging, where data logging is maybe taken every second or something, or infrequent polling or monitoring from supervisory control. Okay, so the first thing you want to do is test each master device to make sure they communicate to each slave device. So in this case, I'm just using our Modbus master tool to pull devices, or pull registers rather, from the slave device on my COM port, in this case, COM 3 and COM 4, but I'll call it master 1 and master 2. So I'm using this master tool to verify that COM 4 in this case is communicating to my slave device. And then we do the same thing with our easy data logger, which I have connected to our COM 3, connected also to the same master. Now I'll show you everything working live in a second, but just want to show you roughly what we're doing. So I have Easy Data Logger pulling the data from the M7026 module at once every second. And then I also have our Modbus master tool set up to pull on a separate COM port. It would simulate like a HMI or a data logger system, and in addition to controllers or other slave devices, or I'm sorry, other master devices connected to the TSH 735. So now for the live demo, this is my system. This is what I have set up. So this is our M7026, which is a Modbus RTU slave device. I have analog input 0 and analog output 0 tied together so we can both see the live data happening and see data changing. This I-7561 is connected to COM port 2 of the module, but it's recognized as COM port 4 on my PC. And the TM7561 is connected to a second COM port on my PC through USB. And this is connected to COM 1 of the TSH 735 module. And then port 3 is connected to the slave device. The TSH 735 is PoE powered, and the Ethernet cable is used for configuration and monitoring. So really it's mainly used for configuration. Monitoring you do once in a while or when you first set up the module. And I also have a power supply over here to power the M7026. Let me show you my other screens. Let's see, let me end the slideshow, minimize that. So let's see, first I want to show you, where is it here? So this is the monitor tab from the TSH module. We're connected live, so we can look at the application mode settings right here. Mode 1, slave device connected to COM 3, and we could scroll through our COM port 1, port 2, and port 3 settings. But most importantly, what I want to show you here is just the monitor tab. The monitor tab currently shows that all devices are off and nothing is being pulled, but I have my Easy Data Logger software set up here so I can start communication to it. I have this pre-configured and we can view live data using the trend curve. So currently we're measuring, let's see, oops, let me turn that off actually. Let me mute that. Okay, so let's see, let's go back to the monitor tab. So right now I'm just going to connect one master at a time. So I'm going to clear everything. And let's see, I believe both master devices are stopped. So let's see, let me minimize the questions really quickly. And let me go back here to our Modbus master tool. So currently we're disconnected, so no communication is happening. We can reconnect and you should see communication happening. This is COM 5, which is connected to, I believe it's port 2. Yes, port 2 of our module, and port 3 is the slave port. So we see communication happening. We're able to change values from this master device. Come on, there we go. We'll change it to, I don't know, 987, and we should see a value just under 900 there, or just over 900 rather. Let's see, and we see communication continuously happening. Now, if we turn off this device and we connect the loud device, it's because it's an alarm condition, but we can see that the values, let's see, are communicating. We're now communicating between port 1 and port 3. And we could change the values here. Oops. Let's go 1, 2, 3, and we do set. And we see a value here change as well. So we're communicating both individually to the master devices. Now I'm going to start up both at the same time. Let's see, let's go here, and let's also pop this up right here. So I'm going to connect, and we'll see that clear data, we should see both these numbers start incrementing and communicating simultaneously. And we can see down here that there's no errors happening. I'm going to shut down Easy Data Logger because it's an alarm condition, because we didn't set what do you call it? We didn't do the proper scaling, but that's okay. This is more for demonstration process purposes rather. Does anyone have any questions? I did see a few in the box. Let's see, let me go back there. Okay, do we have a signal conditioner that can take 6 RTDs and activate a relay contact? Let's see, we do have RTD input modules. It sounds like you need some logic. I'm not sure what's going to trigger the relay contacts. If you have a PC connected, you just need data acquisition modules, but you need to have your PC or something controlling the logic. You can use Modbus RTU or Modbus TCP slave devices, and you can use those in conjunction with our M7000 modules or ET7000 modules to monitor the RTD inputs. Those are not signal conditioners per se, but those are data acquisition modules.
Yeah, we have an Ethernet IO modules, like does the EAT7015 with 7 RTD inputs. Does that support IO pairing where you can have the inputs on that trigger the outputs on another ET7000 module like ET7060 with the relay outputs?
Well, in this case, though, it won't work because you're pairing an analog input or 6 analog inputs with the relay contact. So you would not be able to use pairing with that. You need some kind of controller to trigger, maybe our WISE controller or something to do that. If you
Yeah,
need logic.
maybe WISE 5800 and then M-7015 and M-7060. You can
Yeah.
use those 3 parts together and configure it through a web page to.
Yeah, or even our TMR5 too, but we need some more information on, you say signal conditioner, but not sure at what condition it's going to trigger the relay output. Oh, wait, let's see.
And how many relay outputs?
Yeah, well, let's see. This says activate a relay contact, but my assumption would be you just want an alarm condition if maybe an RTD temperature goes above. But I do see you can call me or Maria. My name is Robert, or Maria after the webinar. We can be happy to discuss this application with you. And then let's see, next question.
And they asked who they can contact as long as it says anonymous attendee. So as long as you can email us or call us, then we'll be able to help you. You can email me at marias@icpdas-usa.com. I'm going to go ahead and type that answer so everybody can see it.
Okay, and the second question I see here is, won't the 48-volt DC have an impact on voltage control signals being transmitted by the Ethernet cable? My assumption would be this is concerning the PoE power. What PoE does is use unused pairs within the Ethernet cable. So within the Ethernet cable, there's, let's see, 8 wires, of which there's either 2 modes for PoE. There's either end span or mid span, where it uses unused pairs or what do you call it? Isolated pairs to transmit power, and it does not affect communication. Okay. Does anyone else have any questions? I don't see any more. Let's see. If you would like to ask them live, please raise your hand in the Zoom interface, and we'll be happy to unmute you, and you can ask the question live. Let's see, any questions? I don't see anyone with a question. I will give it a moment. Any last minute questions or comments?
I did want to mention we do provide training classes, programming classes. So even if you have some sort of project, we can cater the training of our equipment and how to use our equipment. We can cater it around your projects.
Oh, and also, if you do have any topics you would like us to create a webinar on, please, contact us, either our marketing department or us directly. And, we could probably set something up, whether it be for everybody or even for your company alone, if you have a big enough group.
Yes, you can reply to the newsletters and let us know that information.
Yeah.
I see Brett is raising hand to talk.
Oh, okay, perfect. Let's see.
Yeah, hi. I have a we do a controls platform that we've integrate buildings with, mostly wineries in Napa Valley.
Mhm.
And we've been asked for a utility company to be able to do all of the data acquisition for their cogen plants. And most of it's all serial devices we need the data from. What we've learned is that there are some serial communications that are different than others, but what we are looking for an application to be able to unify all that data. I would be interested to know, yeah, if you had a course that would be particular to the application that we're trying to make the application for.
Oh, let's see,
Oh,
that
yes,
type of
definitely.
application actually makes it sound like we should just set up a conference call where we can go over the different solutions once you provide details on the protocols that are used and maybe give us a system diagram.
And then if you wanted, you could come to our office, or we can help you remotely over a web meeting and provide you with that course and help you step by step.
Oh, you cut out.
Oh,
Um,
yes. So like Robert
Okay,
said, we could have a conference call, go over all the details, put together like an application type diagram, and then
yeah.
we could help you over a web meeting or here at our office, for example, and help you step by step with everything.
Where are you located?
We're in Southern California in Lomita. It's kind of near Los Angeles.
Okay, I'll be there this week in
Oh, great.
LA.
Oh, good.
Okay, thanks. That answers my question.
Okay, I do see one more question. Do we have a converter from Foundation Field Bus to Modbus? We don't have a generic converter, but we do have individual converters or gateways is what we call it, where it converts one protocol to another. For instance, if you have CAN bus and want to go to Modbus RT or TCP, we have that. If you have CAN open, DeviceNet, J1939, Profibus, Profinet, Ethernet IP, all of those different protocols to Modbus on individual modules, not one generic module. So if you can let us know what protocol you need to convert to Modbus, we do have gateway solutions for almost all of them. Okay, any other questions? Okay, we appreciate you all spending your time and allowing us to go through this presentation. If we can help on any applications or have any questions about the products or anything, we'll be happy to answer them for you. And please join us next month for our next webinar. Do you have any last minute things to say, Maria?
No. Have a great day, everyone.
Okay, take care all.
Thanks.
Bye-bye.
Bye.